It's a delight to come back and introduce Pete Macler and Ed Kaczmarek for our second podcast. The first podcast I had intended for us to talk about capital investment strategies and how you make those decisions, but we wandered off and did other stuff. This time we concentrated more on capital equipment investments. How do you make those decisions? How do you do the analysis? How do you prioritize them? Those kinds of things. So I think you'll really enjoy it. I look forward to your comments. If there's questions you want me to ask Peter and Ed, or topics you'd like for us to grapple with, or there's other people you'd like me to bring on and do a podcast with, or if you'd like to do a podcast, if you're interested in doing that, please just let me know. And thanks for your attention. I hope you enjoy it. Thanks. This time, wanted to concentrate on capital equipment investment. I've got two general topics that I wanted to talk through. And probably the first one is, within the Department of Energy, I was an active participant in their energy efficiency renewable energy program. And they were anxious to find equipment that would improve our energy efficiency in terms of how much energy does it cost to make a ton of steel castings. Mm-hmm. And they had plenty of MBAs and other people who believed that if they could create a significant reduction in cost, and to them significant meant something over 5%, that we would purchase new furnaces and replace our existing furnaces in our facility. And so one of my primary roles was to come and tell them that that was not going to happen, period, full stop. That the challenge was that we were always capital short. And because we're always capital short, our number one investment is always to do the regulatory compliance that was required, or else they just come and put a lock on the door. And the second priority was people change in our marketplace, needing new capability or different inspection or different kind of processing or something. And so in order to either grow into a new market or to retain my position in a marketplace, that would be my second priority, because if I don't have customers, I'm out of business. Mm-hmm. The third one then, if I had money left over, was really to reduce the labor content of my product, because it not only was relatively high, it's uncertain, and it causes me all kinds of other problems. I did say, if you want a DOE program that's going to encourage people to have more efficient equipment, you need two or three things. One is, if you give me enough free money, you can convince me to make the investment. So if you'll come in and cover 50%, 80% of the cost of new lighting, I may sign on to that because it's a small enough amount of money and a big enough improvement in my workplace environment. I'll do that. Or once every 20 years, my furnace is out of date. I can't get spare parts. I'm going to have to do something. And for me to take advantage of your most energy efficient, I need incentives and a persistent program within Department of Energy or the regional energy efficiency group. So I know the people there and I understand the program, and I contact them and we work something out where I invest in a piece of equipment that might be slightly higher, upgraded, or different than I would ordinarily do, because there's enough of an incentive or enough information about its value that I'm willing to do that. So I thought I'd pitch it over the wall to you, Peter, and to you, Ed. If you had a different framework that you thought people actually used, is there something that goes higher up than the three I listed? And are there people who have so much capital that as long as I get an ROI, I'm going to buy it?
Okay, can I start?
Yes, please do, Peter.
Yeah, well, to me, from a very high perspective, if you can improve your profitability, you'll spend money to do that. I mean, from a very high look. So
you're going to have to look. How much of an improvement in profitability is a big enough improvement for me to pay any attention? Is that a 5%? Is that a 20%?
Oh, you wouldn't touch 5%. I don't think anybody would, but I mean, you'd want a return on investment. Okay, let's talk about an ROI. The old rule of thumb, and it is definitely a coarse rule of thumb, is 3-year payback or less to get the attention of the accountants.
Sure.
Uh, it's a little iffy because if you're building buildings and buying land, the write-off is a longer proposition. So you may, if you're building an entire foundry, you might look at 4 or 5 year payback because of those factors. And it's not precise. So you've got to get a payback to make this attractive. And the 3-year was just kind of a cut and dry thing, that smell test. Let's call it a smell test.
Okay.
As to whether it's a good thing to look at or not. There are intrinsic improvements that don't go into the ROI formula, which may be ignored by the accountants, but have good value long term for the business. So those have to be considered too, and that may put a little different perspective on it. I know in some countries they look at a longer payback as being smart. They're looking for the future. They're doing long-term planning, not 3-year planning, and tend to do a little longer term payback.
Yeah,
So,
what are some examples? You were saying there's some things you'd buy with a longer term payback because it makes broader or bigger business sense. What's an example or two of something you'd invest in that's just not a straight return on investment?
well, I think things that improve working conditions,
Okay.
so that you have a less turnover in your employment. If you can clean the place up, and so many foundries, the turnover is incredibly high, particularly in
Right.
the finishing area or shakeout. And it costs money to just keep this turnstile of people coming in and out every day. It costs money to do that.
Yeah,
Yeah,
there's a
I
line
remember.
there between
I'm sorry. Go ahead.
there's a line there between something that has a financial payback that accountants can be happy with,
Sure.
and other things that might not have something that has a financial payback at all. Perhaps an example of that might be employee facilities.
Exactly.
Sure.
You know, if you have to have them, it feeds back to your point about long-term welfare, encourage people to stay. But there's really no financial payback. It's not an absolute cost of doing business category.
Right.
It's not a financial payback. But on paper, it would have a near infinite number of years to pay back because you're not going to show much money there.
It's interesting because there's two examples I know of that. One is I remember 35 years ago, out in Pacific Steel, Nino Davi showing me that they had replaced painting the doors twice a year on the men's locker room with a stainless steel plate that he didn't have to paint, and the people really liked it. And then a more current example is one of our member companies up in Milwaukee got the group that does McDonald's restaurants to come and do their lunchroom. So instead of picnic tables, they had these little communal areas where friends could sit together, and they put up video cameras or video screens in there. So it felt like you were eating at a McDonald's. And they cited two reasons they did that. One, it made it feel more credible and a warmer environment to the employees coming in. And two, you can hardly destroy stuff that they build for McDonald's. So if you want something that's really hardy, if you go to the people who make McDonald's restaurants, that piece of equipment is not taken care of well at all. So it should survive in a foundry. So I thought that was really sort of a brilliant approach to looking at your employees' break room.
I think that's some of the intrinsic value that I mentioned, and there are other things too. Of course, the cost of doing business with putting dust collectors in. You don't have a choice. If you're going to stay in business, you got to do it. So you're not looking for an ROI on that. You're saying we're going to stay in business. We've got to do this, and somehow we'll have to make it up on some other way to pay for it. And but the primary driver, in my view, from my experiences, and I'm sure it's not everyone's experience, is people want to make more profit.
Sure.
And they can grow the business, make it more tons, or they can improve the processes and have the same number of tons selling product at a higher value per pound and make more profit. Improve the technology within the foundry, not necessarily more tons, but higher value product, more value added product, putting a machine shop in and having control over the machine shop in addition to your foundry. And those are things I think that are driving people today. And this machine shop thing really started when people were importing castings from Asia. Let's just say, be polite and say Asia. They would get scrap castings on machine and say, what the heck? And they said, well, they got to be fully machined before we'll accept them. And then that part of the equation is taken out. We can look at a machine casting, and we bought that. And this stage where we go through the scrap sorting of raw castings is their problem, not ours. So now in the United States, the buyers who are accustomed to buying in Asia are saying, hey, you guys here at foundries in the United States, where's your machine shop? We want that same service.
Yeah, the machine shop is an interesting question. First of all, it was always an irrational commercial transaction selling somebody an unmachined casting, because when they discover things on the machine surface, I never really know how to fix that as the foundry, and you think it's pure cost to you. And so when I talk to foundries about putting in the machine shop, if I put another 1/8 of an inch of finish stock on it, my cost rarely changes for the machining operation, but my quality problems go away. So that was always an irrational problem. The other challenge, though, and I've done some analysis on this, Peter, the machine shops fully recover the cost of their capital in less than 5 years because they know they're going to have to buy a new piece of equipment. And so if you look at the return on investment in foundries, we're pitiful compared to the machine shop. So one of my hopes is that as the foundries go into the machine shop business, that they'll begin to realize the full cost of capital and really try to recover those capital costs, because that's really one of our biggest problems is we don't have enough capital because we don't create enough capital. And that's because our costs that are embedded in the prices of our product don't fully cover the capital costs we have invested.
And that's an argument you've made for years. And it's pretty hard to argue with that, except either there's something else at work or the entire foundry industry, except for Raymond, is really stupid. And so yeah, although there are foundries and more so every day that are doing more and more machining, but there are reasons why historically it wasn't machining wasn't just inherent with the foundry operation itself. And there are reasons why people don't spend the money, even though they may think now, why aren't we in machining? And partly you just have to have the money in some access to that money in some way, and you have to have the will to spend it.
Right.
And if you don't have both of those, you're probably not going to be real fast to put in a whole brand new machine shop section. And so, therein lies, chicken or egg, or how do we work our way from where we are to perhaps where we would like to go? And I say we as an industry, not for me personally.
Well, the only thing I see with that. Go ahead. I'm sorry, I didn't interrupt you.
No, that was it.
Well, the thing I see on that is it may not be the foundry's choice. It'll be the consumer's choice. Say we must have a machine casting. So the foundry can partner with the machine shop, not own it, but partner with it and get to the same end and then ship from the machine shop to the end user. But ultimately, I think that trend is pretty strong. I think it's something that's going to happen.
That's totally logical. It's totally logical.
Oh, and absolutely. Our OEM customers in particular would like us to sell them parts, not castings. They want to be able to bolt it into their equipment. And we are so short in terms of manpower and capacity that when I talk to the foundries today, the customers are willing to finance the capital investment if it will improve the volume and the quality in a way that has a meaningful impact. And so, but that also points out the fact we're capital short. So the foundry industry, being small, privately run businesses, have had a terrible time with the regional bankings beginning to abandon them and the national banks being unwilling to take the risk of a capital intensive industry like foundry. So did you run into that problem, Ed, that the banking system was becoming less enthusiastic? I know a number of our members have.
I'd have to say that you have run into a situation or a topic where I have been retired for a few years now, and that environment is pretty dynamic. And so I'd have to say I don't feel comfortable answering that question with the current state of banking. I mean, I can tell you all the things I read about regional banks right now. and what you're saying is if it was logical 2 years ago is even more logical today, but I don't personally have current experience with that.
So Peter, did you, in terms of the ability to borrow, in terms of your capital access, I mean, historically, your ownership, your book value really was the investment that people had in the facility. And then you might have an operating line of credit as well to operate things. And people tried to manage the line of credit so that they could, in poor business environments, service the debt, but in good business, the stockholders would make more money. And yet we see people really struggling just to have enough money to keep the operation floating. How have you experienced the whole financial structure? I mean, are foundries too dependent on borrowed capital? Are they not exploiting borrowed capital enough?
From my experiences, I rarely get in the inner loop with the banking system from the design of the foundry. Usually the client will come to me and said, let's put together a CapEx plan and we'll come up with the amount of money we need. And then they somehow make it work. So I really haven't done a lot of work directly. I have, for several banks, evaluated foundries and gone through and done an assessment of the value, the equipment value, and then an operational value as an operating foundry versus a non-op. I've done that for several banks, well, more than several, I guess, but that would be my connection, but not on the actual getting the money from the bank, so to say. I don't see that. I'm not exposed to that normally.
Let me also, when you look at financing on some of these things, and you mentioned earlier about getting, I'll use the term free money from some energy department or whatever.
Sure.
There's a piece of equipment involved. Last time we talked about furnaces, and Peter talked about why wouldn't you put in an induction furnace? And if I was putting in a furnace right now, I'd answer that question. Well, of course, we're going to put in an induction furnace, but in most circumstances. But the specific piece of equipment is usually only a percentage or always a percentage of the cost. I
Sure.
mean, hard pressed to think of something where it wasn't. And some types of equipment, if you're looking at it as just as an asset that can be repossessed, so to speak, or financed from some entity, that's only a fraction of the project. And, you know, can you get the entire project included? So if the Department of Energy or someone is going to help spring for some money, are they going to do the whole project? Or are you only looking at, you know, if you're going to put in new lights, are you only looking at what it costs to buy the light fixtures?
Right.
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 Yeah, you could spend a lot of money on a furnace with the installation cost, the dust collectors, and all the ancillary equipment, not just the furnace. I mean, it could be double, you could double or even more than double the cost of the furnace to install.
Where's your power coming from? Do you even
Right.
have a substation? You know, what?
Yeah. Oh yeah, it's fascinating because the foundries who had the stellar reputations of being both high in quality, high in productivity, and high in profitability, one of the unusual characteristics, two that I know of, one is the CEO had plenty of time to come to meetings and play golf. So there's something about running the business well that goes beyond just attention to detail and focus. I mean, there's some kind of culture, some kind of vision, something going on because they were always capable of doing that. The other thing, though, that always struck me was, like if you go down to Hensley now, they spent $1 million to reposition the parking so that they could expand their production in a way that didn't disrupt their productivity. So it wasn't unusual in my purview, and of course I don't see the numbers, but for people to express that to put this piece of equipment in the right place and move all the other pieces of equipment around so that we are efficient and high in quality and minimize handling, that costs as much as a third of the total project.
And when you're retrofitting, you know, you don't always even know what cost you're going to have.
Right.
You know, if you're talking about repositioning equipment and rehabilitating a section of an old foundry,
Sure.
you chip through the floor and who knows what's under there.
Yeah, the thing we talked about last time.
Yeah.
All of us husbands know that when your wife wants to pull up the carpet, it's not gonna there's gonna be a problem there. We all know that. And that's why we're reluctant to do it. One other thing I wanted us to talk about briefly, and it really has to do with the value of the investment. When somebody asked me, and I think I mentioned this last time, somebody mentioned to me about 15 years ago, what does it cost to add a ton of capacity, annual ton of capacity to the physical plant? What's the capital investment cost of the additional ton of capacity? And when I asked that question, I know I said last time it was $2,000 to $10,000. And then I asked Tom Danasek, who is Steel Manufacturers Association, because they were building mini mills out the wazoo, how much does it cost to do a ton for a mini mill? And he said $250. And I was shocked. And that's when I realized it really has to do with the unit value of your product. That if you can make the investment for half of the unit selling price, then that's a really good investment. And if it costs you more than the unit selling price, it doesn't make any sense at all to make the investment. So one of the reasons you don't see new foundries or very little additional investment is because the capital investment cost is well in excess of that. Now you can move those numbers around a little bit, and it goes to the sort of high-end thing that if you want to know how much a foundry is worth before you do any other analysis, if they sold $10 million of product last year, they're probably worth around $5 million. I can move that number up if their real estate's worth more, down if they polluted the site. I can move it up if they have a special market so that their margins and their profitability is 20% instead of 8%. I can move that number around a little bit, But when you look at even the big corporate stuff, the book value is about half of the volume of sales in a year. So that would imply that your ROI, Peter, would really be directly determined by the cost of that capital investment compared to its effect on my either productivity, product value, or volume.
I look at it a little differently. I look at EBITDA, earnings before tax, depreciation, and amortization.
Sure.
There was a study done, and it was published in one of the foundry magazines, I think Modern Casting, probably 15 years ago. And the average foundry, if I recall, and forgive me if I'm off by a few percent, the average foundry sold for 6 times EBITDA.
Okay.
In the range, the really crummy foundries at the low end were down around 2. In the super great modern exotic foundries were up at 10, 12. But the top of the curve, the bell-shaped curve, was 6 times EBITDA.
Wow.
So I think it's still probably a good number to talk around, be a starting point, negotiation.
Huh. That's interesting because the Risk Management Association, it used to be the Robert Morris Association, had the benchmark kinds of numbers. That'd be an interesting thing to see what the current EBITDA is for steel foundries in the latest sorts of market markups, because they report all that stuff. That was one of the sources of data I use when I'm crunching those numbers to figure out what's happening. So that's a really useful, interesting observation.
Yeah.
And lower than almost every other industry. You know, the EBITDA.
Yeah, the lower number. Yeah, we're lower than almost any other industry. I think that could change. My hope is that with the technology we're developing and the changes in commercial ownership, that public policy will change to encourage people to make capital investments. But I'm not particularly optimistic about that, by the way. That's a hope. But the DOD people tell me we're not going to even begin to think about straightening out the mess we're in terms of capital infrastructure until it's broken. Broken in the fact that we're having to fight a war that we don't have the equipment for, or we can't keep the lights on, something like that, which is frightening, by the way.
You talked about energy department.
Yes.
So sounds like they are a little bit different, coming at it from a different approach, maybe, or different place than the Department of Defense. Department of Defense probably figures we don't know what to do, so we'll just wait till it's broken and then we'll know for sure what to do.
Yeah.
As long as you're not the poor grunt on the line when that happens. But the energy department may have money. I mean, is there a prospect where?
Yes.
Does anybody talk about buying equipment, or how much?
Yes. That's a great question with DOE. DOE is fortunate, really blessed today that the next generation of people are genuinely concerned that the way we get our energy today is going to cause the planet to overheat and we'll all die. So they're anxious for us to drive electric vehicles and put up wind towers and solar cells and all that kind of stuff. So they're really deeply concerned about that. DOE likes it because DOE's core mission has always been running the national labs to support nuclear industry, particularly in weapons. And so people think they're there to help us become energy efficient and energy independent. But the DOE's principal function is to really support the nuclear infrastructure for weapons. That's why when a Republican looks like he might actually become president and he's going to can the Department of Energy, they take him behind the curtain and brief him on what the Department of Energy really does. And he decides, well, maybe I don't want to kill the Department of Energy. So climate change has been a huge benefit for Department of Energy. And because it's such a huge benefit for the Department of Energy, they've been able to get $10 billion over the next 10 years to help the economy capitalize decarbonization. And so, yes, one of the challenges I face at Steel Founders is I can't find enough of a workforce. So if I could get a couple of really bright young people, I would have them involved with DOE, because they have a request right now where they want to give $10-15 million away to see how you could use additive to become more efficient at making large steel components. And I could get 2 or 3 of the largest foundries that make those large components and get the DOE maybe to buy them all sand printers and put a program together like that. So there could be some real funding available for DOE. The challenge with DOE funding and DOD funding is the politics moves money, and the political thing is always faddish. And so in DOD world and in science and technology world, if you're not printing the part itself with a metal printer, then you're kind of a boring subject. And so you can talk about additive printing molds, but there's not a huge amount of interest in that. So we're working with America Makes right now. They're supposed to be figuring out how to use additive to facilitate the casting and forging industry. And of course, I tell them that we've been using additive for over 100 years. We call it repair welding, but it's the same thing. And I tell them, while you have the metal molten, instead of making a powder or wire, why don't we just make the part and eliminate the middleman? So there's some really good reasons why our industry ought to be, from a technical standpoint, attractive to making these complex shapes. There's that whole faddish thing. And in DOE, it's going after renewable energy and decarbonization. And that, from a steel casting standpoint, the deterioration of our energy infrastructure, with a tremendous interest in a conversion to full electrification, will create a huge amount of demand for steel castings, no matter how successful or how big of a failure they have. It really doesn't matter whether they're successful at decarbonizing or not, whether they're successful at electrifying or not, because either way, they're going to have to mine a lot of stuff. We're going to have to build a lot of big equipment. We're going to have to build a lot of plants, and that's going to require a lot of steel castings. So I'm really optimistic about both the medium and long-term industry, just from the fact that we're absolutely essential for the kind of infrastructure they need. But it's a real challenge talking to young people. Even my own kids, like Charlie, believes that we're going to solve the problems behind a computer, and they live in a virtual environment. So when you say you got 8 billion people, that requires a lot of tons of stuff being moved around every day. And somebody's got to build the stuff that moves all that around and maintain it and operate it. That goes right over their head.
Well, that's why, I have been in situations where very early in this discussion, you talked about there's plenty of money, and as long as it shows, a company with plenty of money, and as long as it shows an ROI, you're going to get your project approved. That's maybe a bit of an exaggeration, but not much. And I've been in other cases where you're struggling to get the maintenance parts to run today. So we have to get from where we are to the promised land that you're talking about.
Right.
And so how do we accomplish that, is a challenge. Peter will tell us about all the great equipment we should have to do that. And Raymond's going to talk about, well, sure, we should be getting margins and we should be doing this and that. And it's a great market out there in the medium and long term. But, in the short term, we still have to get from here to there. In the long run, we're all dead. So, that's why I just ask, questions like, are there things like Department of Energy? Are there things like, you mentioned earlier, customers may do things, what types of things are customers likely to do? I mean, I could see, and I've heard examples of things like specific machine tools for
Right.
their parts.
Correct.
Um,
Or
I've heard
robotics.
about critical replacement, critical backup equipment.
Sure.
What are things that you may have heard as examples that people could use to go to their customers and say, here's some things that reasons why, it would be good for you to partner with us.
I think that's fascinating, and that's something that would be a really nice thing to follow up with. To me, if you're in the foundry, you need a wish list capital investment plan of what you would do as these things become more difficult, with a back of the envelope ROI and that kind of thing. So that when your customer comes in and wants you to process more of their product, if you buy me a robot that does the grinding, for example, I can double my productivity or triple my productivity. And so I could increase my performance. And I think we need to look at our costing structure and see what really costs we need to identify that would replace and enhance our capital, so that we have a notional sense of what our pricing really should look like. And maybe it goes down. I'm not telling people to raise their prices. I'm just telling them they really ought to have a good understanding, because we had 30 years of selling our excess capital to our customers. After 1981, 1982, when there were too many foundries and too much capacity, we charged just enough to stay in the black in cash flow, which meant that we were basically selling that excess capital investment. We took 20 years to sell it all off. So it was 2002, we finally liquidated that excess capital investment. So I used to go to some of the big OEMs who wanted us to see if there were other ways we could lower our costs so that they could buy things at less expensively. And I told them we already did that for 20 years, and now we were going to have to rebuild. And every dollar I needed to rebuild was going to come from them, and it pissed them off. And you go, that's just basic economics. You come through my facility, you say, I need new equipment, and you're my biggest customer. Where do you think it's going to come from?
Yeah. Do you ever hear, either of you, I don't want to just keep coming back to one example, but once we use it, it's, a little clearer in people's mind, talking about arc furnace to induction furnace.
Yeah.
Electric utilities hate arc furnaces. It makes the power grid ugly, dirty.
Yep.
Anybody ever talk, usually they just come and complain about, you're making my system dirty. Anybody ever go back to the power company and say, you know what, I can help you out, and here's what you can do to get there?
Interesting. Yep.
I think I should check with one plant down in Tennessee that actually converted from their arc furnace to an large induction furnace recently. I do know that in Wisconsin, your past neck of the woods, Charter Steel put in that wire mill, and they were the very first DC arc furnace made in North America. And they did that because the Wisconsin power grid couldn't tolerate a regular AC arc furnace. And so they got money from Wisconsin Power to put in that single electrode arc.
So there is an example of it.
Yeah. Oh, yeah. 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 And it's interesting. It'd be an interesting question for the new core people. How much flack they get for putting in their arc furnaces.
Well, I don't know, but I suspect that they're just so big,
right,
that their system is set up to link into the grid in such a way from the very beginning that it's really not going to be a problem.
Yeah, it's yeah, you're talking a small 100-ton arc furnace or a big 300-ton arc furnace. Yeah.
You know, I
Pretty,
mean, the places that are running arc furnaces typically are older, and they're older, and typically means they're in cities somewhere, and they were just an add-on into the grid at that time, and nobody cared. Now they care. Okay, what are you willing to pay me for that? We could fix that.
yeah, I think you're right. I do think we're going to have to become creative that way because the infrastructure limitations may create a real interest in changing our capital investment. So, Peter, what's a capital investment that most foundries should be making on an ROI that they're either unaware of or they think it's not core enough to their business? What's a couple of examples of ROI, really good projects that you think are underutilized?
I'm not sure I've got my arms around the question.
Okay.
So, yeah, well, some of the obvious ones are putting in sand reclamation.
Okay,
So
sure.
you can generally get a pretty good payback with sand reclamation if you're not reclaiming. So that's a typical one you can add on, and it's quite popular now. If you're looking for that type of an answer.
Yeah. And one of the things that was interesting is early on, people bought a sand reclaimer to try and do all the maximum load. And then, of course, they realized that turning the thing on, turning it off was a bad idea. And so they reduced the size of them so that they could keep it operating 24/7, even though they weren't reclaiming all of their sand. But I've heard some things recently that made me think that people are going back to a larger reclaimer, trying to reclaim a larger percentage, which would mean they'd have interrupted operation. Have you seen any of that?
Well, it depends on the cost of your aggregate. If you're into ceramics, you want to get back as much of that as you
Oh, sure.
possibly can. So that would drive that one. That if you get more back on the ceramic, that's money in the pocket, big
Sure.
money.
Yep.
So, in the old days, you threw 10% away of silica, it wasn't a huge hit. But if you throw 10% of your ceramic away, it is a hit. So
That's been fascinating. Early on, a number of people, and it's still a common practice, capitalize the investment in the ceramic and try to keep, they have to be below 2% loss every cycle through, but they're really striving to get below 1% loss. And so part of their repair and maintenance budget is putting that 1% back in, but it's part of their capital structure. It's not a consumable in their financial system.
well, I think if they can do that, it's wonderful. But from my experience in the past I won't mention names, but a foundry that was 100% zircon casting steel, they shot for 5% because they knew they were going to lose a couple percent to floor sweepings and dust collectors, regardless of what they did. So 5% was their bogey. I mean, I admire people for talking about 1 or 2%, but I think if they go over a couple of years of experience, I doubt they're making those numbers. I really do.
It's interesting because they really did talk about a complete reorientation of their people. And so in the kind of foundry you're talking about, if there's a little bit of sand dripping on the floor, it gets thrown away. These
Right.
folks are saying, yeah, no, that sand gets put back into the system. We
So
sweep it up.
you're going to hire additional people to sweep up the sand. Now you better put that into your cost figure.
Oh, sure.
It's not free. You can do it. You absolutely can, but you better figure on that cost being added to your overall operation.
Yeah, that's interesting because, of course, they're trying to get a change in the culture so that the people
Listen, it's wonderful to talk academically about culture, but you got to talk about profit. If you don't have profit, there's no culture there. You don't have a place to work in. So you can't escape it. You've got to make a profit. And,
Wow.
that sounds very capitalistic, but that's the truth.
Absolutely. You can't.
If you look at, earlier in the discussion, we talked about the steel foundry cost, compared to mills.
Yes.
Mhm.
So where is all that extra labor going?
Oh, we sell information. We don't sell steel. And so we're selling that complex geometry that requires all of that labor content, as well as all of that. If you go from selling in $600 a ton, it's $100 of labor. Yeah.
It just walking through an iron foundry versus a steel foundry, where is all that labor cost?
Oh,
Not all of it. It's in finishing. It's in hand.
absolutely.
Welding.
And so, asking Peter, where is some good payback projects? To me, money gets spent on a big new molding line.
Mhm.
And then, well, we'll just throw in some finishing stuff over here somewhere, and we're not going to think about how we can make stuff more efficient because we'll just deal with it. It's no big deal. We're going to have this new molding line that we can put a plaque with somebody's memorial name on it or something that they can look at. If you're
there's some merit to capital investments, so you don't have as much welding and finishing. I mean, they're higher quality sand and more consistent mold hardness. I mean, I'm preaching to the choir here. So
I'm trying to look at what, in terms of spending money.
Right.
Because you're back to, you got to make a profit. We have to get from here to the promised land in the medium and long term. And, are we really looking at things that improve our efficiency where we have all these labor dollars, and what's going into there? What's triggering all that expense and all those labor dollars? It's probably not a dramatic amount of capital dollars like replacing a 25-ton arc furnace might be.
I agree. It's a lot of practice rather than capital. I think it's a lot to do with how the people are trained and maintenance, the quality of maintenance on equipment, so you get repetitive results. I think a lot of that goes into eliminating all the finishing work. I mean, the old expression was make the casting in the foundry, not in the finishing. Well, that was an adage that was hit mostly on steel foundries, that there's so much labor in welding and grinding and finishing that.
So Ed, I knew a guy in Wisconsin who used to be a metallurgist in an iron foundry, and he came over to Milwaukee and started running a steel foundry. And his passion was, if we just spent enough time up front engineering the system and getting the rigging right, and then got control over the process, we could eliminate welding on these small, high volume steel castings. I think you knew that guy. What happened to him? Was he? did the steel foundry eliminate all that finishing?
No, and therein lies, how do we get from here to there? And
Sure.
Some of that is practice. Some of it's, if you're running old junk equipment, you can't get the repeatability that Peter talked about.
Sure.
Some of that now is not necessarily, a lot of it is practice. A lot of it is how do you make a quality part up front. Some of that is big capital dollar items. I'm trying to avoid those and say there are other things that can help you. Sure. Some of it is doing things like the discussion about putting in a machine shop. If you got to put another 1/8 of an inch of finish on there and you can machine that off for almost nothing, you improved your quality. You might, and you can also take care of a lot of your gating connections in the same process,
right?
So that you don't have to, go through a sequence of arc error and everything else. And so the technology does change and can help facilitate some of those changes.
So one of the things I've always observed is if you look at like medium-sized ductile iron castings, there's no reason for them to be less expensive when they're custom jobs. but the big grand difference in pricing between them is really the labor content. And the labor content in the steel foundry is in many ways an artifact of the low levels of volume that we have. And so the automotive guys have come after me from time to time, and having worked at Saturn, I'm well aware that they don't do rework. If there's something I have to do more than 10% of the time, it's part of the process. I buy the piece of equipment so that
You're
no
talking
one has
about
to touch
an
it.
iron foundry? Or
Yeah,
a
even in
machine
an iron
or a,
foundry. Yeah, in an iron foundry. When I worked at Saturn Corporation, we put in you could do one of these Six Sigma lean manufacturing projects to try and eliminate flash, and you'd come to the conclusion that you couldn't maintain the tooling with enough precision not to have flash. And so ultimately it was a better ROI to put in a machine to make sure you trimmed off the flash.
yeah.
Right.
Right. And so, but there you're meeting Six Sigma quality, not because you've done root cause analysis. It's because you're forced to, you're compelled to, because you're making a part a minute or a part every 15 seconds. And you just can't tolerate not having the material flow through. So how much of it do you think? I've always thought that if we ever really did automotive, we'd get there pretty quickly, because most of the things they've done in ductile iron would work for steel castings in terms of making that kind of quality. You might have a higher cost because of rigging or the cost of machining, but you'd still be able to get there pretty quickly. But I don't know any reason why anyone would invest in that steel foundry, because why you'd ever want to work for the automotive companies would be really a challenge. I don't know why they'd want you to get your competitor fully up to speed so they could compete you against them, so you couldn't make any money. So,
Well, there are a couple of differences there between iron and steel, and having spent quite a bit of time in both, I'll just do a short version. One of them is, besides the lower volume and generally older equipment base, I'll say, in steel, you are dealing with higher temperatures, and that does raise some issues that make it a little more difficult on the casting quality, repeatability issues or question. The other one is that iron people, their mind gets focused very quickly when you have to throw any defect away. There is no welding.
Yep.
I mean, theoretically, you could do it, but you're not set up for it, and you can't waste the time on it.
Right.
And so that part is scrap. And I said that helps to focus your mind very quickly. The old adage that, steel casting buyers used for many years. One of you want to say what it is before I do?
No, go ahead.
Steel casting is a mass of blowholes and slag connected with weld wire.
Of dubious quality.
Yeah. And people will jump through all kinds of hoops to salvage that casting. The iron people throw it away and say, we have to fix it.
But on top of that, though, in fairness, to me, some of the top iron foundries in the world here in the United States, I won't mention names, but they count scrap in parts per million, not percent.
Yeah.
They're that good that they can count it parts per million.
Yeah.
And so they've got the process down. They've got it made, and they've earned it.
Oh, I think that's right. But if you don't make 1 million parts a year, you can't count parts per million, period, full stop. And so one of the challenges we face is, if I look at the Ann Arbor reports on returns from customers, not scrap, just returns from customers, okay? Returns from customers, steel foundries were actually slightly better than the industry as a whole in returns from customers, lower in how many returns for customers. Typically, foundries have between 0.5% and 1% return from customers across the board, which means 10,000 parts per million. So when the big OEMs would ask me about steel foundries, we were better than that. We were like 5,000 parts per million. They were trying to get us to 20 parts per million. But when you're only making 20 parts, what counts as a miss? I mean, what counts as a miss? I can tell you that there are plenty of misses in the people who have that many parts per million. They may not count the warm-up cycle. They may not count the close-down cycle. They'll only count their true production cycle. And so, and if there is something that you need to do to meet the number, and you can't do it with tooling or process control, you just put another machine in. So it's part of the process. That's how you make 6 parts per million. So you're correct. They're much better because they have to be, which is what Ed was saying. They are much better. There's no question they're much better. But the metrics are really sort of screwy too. And the capital structure is different because because I can't afford the scrap, I can put that piece of equipment in.
True.
Yeah.
But you simply add welders in the steel foundry, which that's not, to me, that's not comparable because your prices are much higher because in part with all this finishing and welding.
Yeah, yeah.
So I can't see the comparison is really good when you compare a high quality ductile iron foundry with a steel foundry in returns, because to get to that point, you had to spend hours and tons of welding rod to get there. So I'm not sure I wouldn't give that much credit. I don't think that's a good thing.
One of the challenges is, though, the reason the iron foundries can be there is because they're making 200,000 parts. You couldn't do that. There's not enough volume of work to carry the administrative overhead to get that good when you're only making 5.
Well, the old journeyman foundryman might say they could, and they'd get their water bottle and slick out and do it.
Yes.
Right?
Yeah.
Okay.
Yeah. No,
I'm sorry.
No. You really are operating in 2 or 3 different kinds of business environments with financial structures and technology. So you're right. They're not directly comparable. I've crunched the numbers before. I mean, because of the high silicon content, we have about the same energy requirement in both of them. High production ductile iron can have riserless, but if you're making 1 or 2 of something, the yields become close to steel castings, depending on the shop, but become close. We spend a little bit of more money in heat treatment, but the quality thing depends on the volume. If you're going to make a 500-pound casting and sell it for $1,000 and you're only making 3 of them, how much money do you have to screw around with doing the engineering? Even the guy buying it doesn't have that much money. And so you really are in a situation where you're making custom proprietary parts in small volumes. It's a real challenging environment that Ed knows better than either of us.
Yeah, understood.
How much of that, what I just said, fits true? Because you were in the iron shop and then you were in the steel foundry.
Yeah, actually, I started in steel, then did iron for the whole middle part of my career, and then went back to steel. So, yeah, I had a chance to go through the different cycles. But a lot of it is, I mean, everything we've talked about is a part of this equation. How much you emphasize any one portion of it. I personally have always liked big data. But where do you get big data in a steel foundry? It's
Right.
not so easy. In the iron foundry, I could give you just head spinning examples of what big data allowed us to learn and to improve. because we had big data, and when we did, and we asked the right questions, it was absolutely astonishing what came out of that.
Yep. Oh, I think that's right. I mean, when I worked for Saturn for 11 months, and so to get my head around it, they had to educate me about automotive volumes. Saturn was the smallest car production facility that you could justify economically, and the smallest volume car that you could produce that would allow you to have a sustained operation, at least at that time and in that organization, was 250,000 units a year, which made the math simple. It's a car a minute. You had to make a car a minute. So if you needed four of the same parts for one car, you had to make them in 15 seconds. If it took you 20 seconds to make it, you had to have two processes so that you could make four every minute. And that was fundamental to the whole infrastructure, the whole way of trying to understand the process.
Well, if we made 1 million pieces on a part, for example, ductile iron, high volume ductile iron, 1 million pieces a year on part number XYZ. And I'm just going to pick some random numbers to try to keep it simple. But as an example of what big data did, and maybe there's more there we ought to be doing in the steel foundry business, but if that part is 18 on, which is entirely possible, and you look at the scrap, because you're not doing any rework, it's either good or it's scrap, and the scrap rate on that part is low. The scrap rate on that part, I'll say, is 0.5%.
Okay.
You can argue that's high, but I'm just picking a number. Okay, but if you actually look at it by cavity, you can find out that 95% of all of that amount of scrap is coming from one of those 18 cavities. And you make enough of them that you can get big data that when you look at that, it jumps out at you and you say, voila, what's
Sure.
wrong with this? You pull a pattern out and the gate has a notch in it, and it's like, fix that, boom, the scrap just went down. If you looked at the gross scrap on that part, you would say, really not even waste our time working on
it. Right.
Because there's something else. But it was a really simple fix once you actually had the data.
Well, I mean, it's the same problem we run into comparing the quality of our steel with the mini mill, because the mini mill knows that the first 100 feet of steel they make is filled with inclusions and crap, because you're warming things up, you're getting all the oxygen out of the system, you're getting any of the slag that's left over and trapped. You know that that's going to be crappy, so you don't even think about selling it. You just make that first 100 feet, cut it off, throw it back in the furnace. Well, the first 100 feet is all we ever make.
But this discussion was on capital dollars, and I kind of veered us off on a path, but part of it was to say, if you're looking at payback on some projects, maybe we need to do a better job of putting in electronic controls on things now with the Internet of Things, and,
Sure.
and doing more monitoring and collect some of this. With the modern measurement techniques, we could get big data out of steel. Because we can collect more data now than we used to in an automated way. And if we could do some of that through control systems, and if we could do some things with improved process control, that then we could automate more downstream of parts going through finishing, there might be a really good payback there that doesn't require $10 million up front.
Yeah. 20 years ago, I thought, we know what the casting is, what its orientation is, and what it is when we make the mold. And we have to relearn what that casting is and what its orientation is 20 times, 30 times, 40 times in the process of making it. Why don't we just reach in at shakeout and grab it in that location? And then we know where the gates are. We know where the risers are. We can just take it over and continue to process it. So I do think there's some tremendous opportunities with the sensor technology. And I wonder how much of that value will be driven by just being able to do activity-based costing. So we actually have an accurate system of what it costs us, which would identify the ROI opportunities in that whole manufacturing process.
Yeah.
Last thoughts, Peter. What do we haven't talked about in capital that you think people ought to know?
Oh gosh, biggest problem I've run into are projects that are generated internally, and cost estimates are generated internally, and then I'm called in to take a look at the project. And it happens more often than not that the plant manager has told the engineers, we got to have this project, we got to make it, keep the costs down so we can get it through the board and get it approved, only to find out they're $3 million short at the end of the project. So, from my perspective, I see that a lot, where the internal estimates, I don't know if they're intentionally low or just because of lack of experience, they don't include the factors that occur during the project, but they always end up lacking the funds at the end of the project. So I watch for that carefully when I do an estimate, because well, I've seen projects where it's been more than $3 million where the internal estimates were off by great sums of money. So I guess that, from my perspective, is one of the most important things. Get your numbers right. Make sure you've got everything in your numbers before you get started.
That's good stuff. Ed, last thoughts. What do we haven't talked about?
Well, we haven't talked about prioritizing projects, off of the laundry list of wishes that people have. And
Sure.
That's another whole topic, because it usually isn't a question of just one project and what are we going to do on this one project. It's a question of, we have 5 or 10 or 20 projects, all of which are worth doing, and how do we prioritize those? And all the individuals involved, how they can look at it and say, how can we work together to get the best list, and recognize that things happen, like Peter said, that even with the best of intentions, if your project is number 2, that's no guarantee that it's going to get done after number 1. If number 1 overruns the budget and there's no more money, you don't get to project 2. Or by the time you finish project 1, a new customer came along that's a great opportunity, and you say, hey, we can't do this prefigured project. We're going to have to do something. We're going to have to put in a machining center to handle this great new customer. That has to be the new next priority. And so there's a whole thought process there that I think a lot of people get upset about in foundries, because their project didn't get done, and they get mad about it. And so there's things that happen, there's reasons why things that get done for the most part. And that's a little bit more of the human nature part of capital spending, but it's still important.
Yeah, that goes back to one of the things I started with. Yeah, that you gotta invest in your environmental stuff regardless of ROI. You've got to protect your markets or service your customers, and so you have to spend that money. And then when you start looking at the discretionary uses of the capital, it's not easy from a strategic or business standpoint to really know which decisions to make. And then, of course, ROI becomes a big factor. But ROI, being a technology development guy, I'm fundamentally, Peter, skeptical of ROI calculations. I can see in a production environment where you can characterize the costs and really realize that it makes sense. In the technology world, those numbers are all made up.
I understand.
Yeah. And you're well aware of that. There's no way of saying I'm going to get 20% of the market with this kind of profitability 5 years from now.
No.
You're just making the numbers up. This has been interesting conversation, fellas. I always enjoy the time with you. I hope you enjoyed this podcast. And as I said at the very beginning, I'm hopeful that you'll give us some feedback on what you'd like to see, what you'd like to see different, who else you'd like us to talk with, what topics you might want us to cover. So I look forward to you giving us some feedback so that we know exactly what we can do to add value to what you'd like to see. Thank you. Bye.